Okay, let's dive in. Imagine this. You spot a tiny, tiny speck from hundreds of miles away in space.
Uh-huh.
And you realize that speck is actually a robot explorer, and it's driving across the surface of Mars.
Yeah, it's pretty mind-blowing when you put it like that.
That's exactly what we're looking at today. NASA's Curiosity rover caught on camera from orbit while it was actually on the move.
And what's really significant here isn't just the image, though it is stunning.
Right.
This picture, taken by the HiRISE camera on the Mars Reconnaissance Orbiter, the MRO.
MRO, yeah.
We think this is actually the first time we ever gotten an orbital photo of Curiosity in the middle of a drive.
The very first time, while moving.
That's what it looks like. I mean, think about the coordination needed for that.
It's staggering. Like trying to photograph a specific beetle walking across a massive desert from an airplane, but timed perfectly as it moves.
Exactly. It gives you a sense of the scale and the challenge involved.
Absolutely. And that's why it's so cool. So today we're going to unpack what this image tells us, why it's such a big deal for Curiosity's mission.
And look at where Curiosity is going, its science goals, all of that.
Yeah, the details we've pulled together really paint a picture.
And, just stepping back for a second, this one photo perfectly shows the teamwork, really, between the orbiters and the rovers.
A coordinated dance across millions of miles.
Precisely. A huge interplanetary effort.
Okay, so let's zoom in on the photo itself. It was taken February 28th.
That's right. February 28th, which was Sol 4466 for Curiosity on Mars. A long mission.
And the camera, as you said, was HiRISE on the MRO, that super sharp eye in the sky.
Yes, the high-resolution imaging science experiment. And it's worth stressing how unusual this capture is.
Because we have seen Curiosity from orbit before, right?
Yeah.
It's just stationary.
Exactly. We've seen it parked. But
Yeah.
catching it mid-drive, that speaks volumes about the precision of the rover's path prediction and the orbiter's timing.
And HiRISE itself is just incredible technology.
Oh, absolutely. It's basically the most powerful telescope lens we've ever sent to another planet. It can spot things smaller than, like, a coffee table from orbit.
Wow.
So catching Curiosity, which is car-sized but still tiny from up there while it's moving, yeah, that's quite something.
And the picture actually shows the evidence of that movement, doesn't it? You can see tracks.
You can, clear as day. A trail stretching back about 1,050 feet. That's around 320 meters.
It's a decent distance on Mars.
It is. And what's interesting is how long those tracks might stick around.
Oh, yeah.
They think they could be visible for months, before the Martian wind eventually just sweeps them away.
Months. So it's sort of temporary signature on the landscape.
A fleeting record, yeah. Etched in the dust for a little while.
And those tracks, they represent about 11 different driving days, starting back in early February.
That's the estimate, yes. Roughly 11 drives starting February 2nd.
Now, Curiosity isn't exactly speeding. Its top speed is what, 0.1 miles per hour?
Yeah, something like 0.16 kilometers per hour. It's slow and steady, very deliberate.
Which makes sense for exploring alien terrain.
Absolutely. Methodical is the name of the game.
So where was it going? You mentioned the context is key.
Right. At the time of the photo, it was moving away from an area called the Geddes-Valles Channel.
Okay.
And it was heading towards a really interesting spot, a region known for these things called boxwork rock formations.
Boxwork formations.
Mm-hmm.
What exactly are those, and why are they scientifically interesting?
Imagine, like, a honeycomb structure made of rock sticking up from the ground, thin walls or ridges forming compartments.
Okay, I can picture that.
Scientists think these formed billions of years ago. The idea is that groundwater flowed through cracks in older rock, and minerals in that water precipitated out, lining the cracks. Then, the softer rock around these mineral veins eroded away over time.
Leaving the harder veins standing, like little walls.
Exactly, like the structure inside a box. And finding clear evidence of this process, that would be huge.
Because it points to liquid water.
Significant amounts of flowing groundwater, potentially billions of years ago, which of course is key for figuring out if Mars could have ever supported life.
So, for you listening who love those aha discovery moments, this place Curiosity is heading to, it could hold some major clues.
Definitely. It connects back to understanding the bigger picture of Mars's history. Was it wet? Was it potentially habitable?
And it shows the strategy, right? It's not just wandering aimlessly.
Not at all. Every meter is planned. It's slow, yes, but it's incredibly focused, driven by these key scientific questions.
But navigating Mars can't be easy. What sort of roadblocks does it face? literally and figuratively.
Well, there are quite a few challenges. The rover uses software for a lot of its navigation.
Autonomously.
But to a degree, yes, it can identify obstacles nearby and plot short routes. But the terrain itself is tough. You've got sharp rocks, steep slopes, sand traps.
Things that could really slow it down or even get it stuck.
Exactly. So the speed and the route depend heavily on how difficult the ground is. It's not like driving on a paved road.
And the team back on Earth plays a huge role in this, I assume.
Oh, absolutely crucial. The engineers at JPL work hand in hand with the scientists.
How does that work?
They look at the latest images, the data coming back from the rover, and they painstakingly plan out each day's drive, or Sol's drive, I should say.
Balancing safety with getting to the best science spots.
Precisely. It's a constant collaboration.
And we actually got a little insight into the day this photo was taken from Doug Ellison.
Yeah, Doug Ellison, who's the planning team chief for Curiosity at JPL, he confirmed that right when HiRISE snapped that picture.
Yes.
Curiosity was almost finished with a planned drive of about 69 feet.
Wow, that's specific. It really shows the level of detail they work with.
It really does. It's this amazing interplay between the big science goals and the practical, day-to-day, meter-by-meter reality of operating on another planet.
So let's talk a bit more about the image itself. HiRISE is designed for high spatial resolution. What does that mean for the picture we see?
It means incredibly sharp detail of the ground, but to save on data bandwidth, which is always precious.
Right.
Most HiRISE images are mainly black and white. They usually include a narrower strip of color down the center.
Okay. So did we get Curiosity in color this time?
Actually, no. Just by chance, on this particular pass, Curiosity happened to fall within the black and white portion of the image frame.
Ah, okay. So a monochromatic view this time around.
Yep. Still incredibly valuable, of course. The black and white detail is more than enough to see the rover, the tracks, the terrain.
And what does that terrain look like in the photo, besides the tracks?
You can see the tracks leading right up to the base of a slope, described as relatively steep.
And Curiosity had to climb that.
It did. And we know that since the photo was taken, it successfully made its way up that slope.
Making progress towards the boxwork zone.
Exactly. The current thinking is it should reach that new science location within about a month or so.
So we caught it just before another climb, heading towards potentially groundbreaking finds, like watching an explorer pause before the next big push.
That's a great way to put it, and it's worth remembering the Explorer itself, Curiosity.
This car-sized mobile lab.
Right. It's been up there since 2012, hasn't it?
Landed August 2012, yeah?
Yeah.
Studying the geology, the climate, looking for signs of past habitability.
Doing incredible work. And it was built and managed, of course, by NASA's Jet Propulsion Laboratory, JPL.
Which is managed by Caltech in California.
Correct. And it's all part of NASA's bigger Mars exploration program.
Which isn't just about understanding Mars's past.
No, it's also paving the way for eventual human missions. Learning how to operate there, understanding the environment humans might face.
And we can't forget the other player here, the Mars Reconnaissance Orbiter, MRO.
Definitely not. MRO has been orbiting Mars since 2006, a real workhorse.
Doing its own science, too, right? Studying the atmosphere, the surface, even underground layers.
Absolutely. With a whole suite of instruments. Plus, it acts as a vital communications relay for the rovers on the surface.
Sending data back and forth.
And, as we see here, taking these incredible high-resolution pictures with HiRISE.
Which itself is a partnership, operated by the University of Arizona.
That's right, operated by U of A, and it was built by BAE Systems up in Boulder, Colorado.
So multiple teams, multiple institutions involved in getting these views.
It really takes a village, or maybe a planet, to explore another planet. It highlights the sheer amount of tech and teamwork behind that one little speck in the photo.
So if we tie this all together, the big takeaway here is really the achievement itself, right? Catching an active rover, driving on Mars from orbit.
It really underscores how far we've come in exploring Mars. And it's a testament to the dedication of, all the scientists and engineers involved.
Absolutely. And it puts a spotlight back on where Curiosity is heading.
Yeah, those boxwork formations. The potential to find real evidence of ancient groundwater there is just, well...
It's incredibly exciting. It could rewrite some of our understanding of early Mars.
It could offer a much clearer glimpse into whether Mars was once a more Earth-like, potentially habitable place.
It really makes you pause and think. The technology, the coordination, sending commands across space, having an orbiter perfectly positioned.
To catch a rover in motion hundreds of miles below, all to understand our neighbor planet and our place in the universe.
It just leaves you wondering, doesn't it?
Yeah.
What other secrets, what other hidden histories are still waiting for us on Mars, just waiting to be uncovered?